Influenza or the flu affects about 5 to 20% of Americans each year and causes an estimated 3,600 fatalities. It is a viral infection that causes runny nose, cough, chills, fever, head, and body aches and nausea as well. And basically, the way these viruses spread is like if you have a person that it's coughing or it's sneezing, so it releases droplets into the air, or if you come in contact with a contaminated object, then the virus then attaches to the infected cells of the respiratory tract, so basically the lungs, if you will. So emergent diseases occurs for the first time in humans, and to be quite honest with you, they're actually becoming more and more common. Some examples of emergent diseases are avian influenza, the swine flu, MERS, and the Zika virus. Whereas a re-emergent disease, it actually reappears after a significant decline in the incidence. And some examples are Staphylococcus and Helicobacter pylori or H. pylori. Now, H. pylori has been linked to ulcers in humans. This is an image that shows the emergent diseases by year. So what we can see is that they're actually becoming more and more common. So some examples of emergent diseases include the Ebola outbreak in 2014. You actually have the SARS in 2003, the avian influenza in 2013, dengue in 1992. As you can see, they're basically spread throughout the world. Again, they're actually becoming more and more common. Coronaviruses is a group of viruses, and their name arises from their crown-like spikes emerging from the virus surface. It is actually quite common in animals, and some other animals that are affected by coronaviruses include bats, camels, birds, livestock, and humans. The first human case was back in 1950, and it was associated with mild case of the common cold. Now, when it comes to livestock, such as, for example, chickens, pigs, and cattle, coronavirus actually causes mild respiratory and intestinal disease. And in humans, it is the SARS-MERS class of viruses that causes actually the disease. And I think we're actually quite familiar with COVID-19, right? Because there was actually a pandemic there. Now, the SARS-CoV, it's a more severe form of the human coronavirus. It actually has a fatality rate of 10%. And, it was thought that it had originated in bats and cyber cats, and then it was transmitted in humans. The first case appeared back in 2002 and actually spread, causing a global outbreak in 2003. And thankfully, there were no more cases in 2004. However, throughout the world, it actually caused 8,000 cases and 774 deaths around the world. So MERS is actually another type of coronavirus that is known to cause respiratory problems. When it comes to the host animal, we don't really know. However, it has been found in camels and bats, and can be transmitted between individuals by close contact. It causes pneumonia and kidney failure, and it has a mortality rate up to almost 35%. Now, this one we actually are quite familiar since we recently experienced this. So the SARS-CoV-2, it was a new form of the coronaviruses that actually causes respiratory disease. We think that it emerged in the Wuhan province of China. Now, it was highly contagious, and it quickly became a global pandemic. It infected hundreds of millions of individuals around the world, and actually also caused a lot of deaths. It actually caused global disruption of society by impacting travel, economies, and social interactions. I think all of us are actually quite familiar with this one since it basically disrupted our lives. So let's talk a little bit about antibiotic resistance. Now, I'm going to keep saying this because I think it's extremely important. So if a doctor prescribes you a medication for, let's say, for 10 days, a lot of times what happens is that the patient, halfway through the treatment, they actually feel better and they stop taking the treatment. Now, that's a really bad idea. And the reason for that is because you are applying a selective pressure for the bacteria to evolve. Now, to be honest with you, there are naturally occurring resistant bacteria out there. And so what happens with this bacteria is that they're actually really good at talking to other bacteria. And what they do is they exchange genetic information, so that way other bacteria can actually become resistant to the antibiotics. And also bacteria are really good at dividing. So here we actually have petri dishes that actually shows the progression of antibiotic resistant bacteria. So on the left side, you actually have a petri dish, what you can see here is that the majority of the bacteria are going to be susceptible to the treatment, and there's only a couple of bacteria that are resistant to the treatment. And so whenever you apply the treatment, so here shown in the middle petri dish, what you can see is that the majority of the bacteria are going to die. However, the bacteria that are resistant to antibiotics are the ones that are actually going to survive, and they're going to start exchanging genetic information with other bacteria, and also they're going to start dividing. And on the right side, what you can see is the last petri dish. What you can see there is the majority of bacteria are resistant to the treatment. Now, Alexander Fleming, who was the famous scientist that actually came out with antibiotics, specifically with penicillin, and one of the things that he warns us about is that the bacteria was going to come in and fight off. And eventually, essentially, what he was warning us about is that bacteria was going to become resistant to the majority of the treatments that we have. And that's exactly what is happening now. Tuberculosis, malaria, gonorrhea, Staphylococcus aureus, and Enterococcus are only a few examples of organisms that actually have become resistant to the antibiotics or the treatments that we have. And to be quite honest with you, more and more organisms are actually becoming resistant to the drugs that we have, to the treatments. And I want to emphasize here one more time, this is why it's extremely important for us to follow directions as prescribed by your doctor in order to avoid the bacteria become resistant to antibiotics. Alright, so what are some of the things that we can do in order to prevent the bacteria from becoming resistant to antibiotics? Well, as I've been telling you in this presentation, take your medication as prescribed by the doctor. Do not skip a dosage and do not discontinue just because you feel much better. And please, this is extremely important because I see this mistake happening all the time. Do not take antibiotics whenever you have a cold. And the reason for that is because a cold is caused by a virus. And antibiotics are actually meant to treat bacterial infections. So what you're doing there is, again, you're basically applying a selective pressure for the bacteria that you have in your body to become resistant. And do not save unused antibiotics or the antibiotics prescribed for a different infection. Each year in the United States, at least 2.8 million people become infected with antibiotic-resistant bacteria, and that results in up to 3,500 deaths each year. Again, these are the small things that we all can do in order to prevent a bacteria from becoming resistant. It's extremely important that we follow directions in order for us to actually have a treatment